Welcome to the lesson on Java Primitive Types, Part 2. In the previous lesson, Java Primitive Types, Part 1, I spoke about the 8 primitive types: byte, short, int, long, float, double, char, and boolean. We're now going to build upon that by talking about primitive type promotions in what is called widening and casting in what is called narrowing. We will defer the narrowing to a subsequent lesson in Part 3 and only talk about widening in this lesson. There are 4 rules you want to keep in mind. All byte, short, and char within an expression promotes the expression to an int type. Number 2, if one operand is a long, the entire expression is promoted to a long. Number 3, if one operand is a float, the entire expression is promoted to a float. And number 4, if one operand is a double, the entire expression is promoted to a double. Let's take a look at how these rules apply in code. Let's say we have a variable called b1, it's type byte, equals 7. Another variable, s1, type short, equals 16. And we wanted to add these two variables to each other, b1 plus s1. And let's say we wanted to assign it back into type short. The compiler does not like this because it does not follow rule number 1. And why does it not follow rule number 1? It's because, like it says, the whole entire expression, if it has a byte short or char in it, is promoted to an int. So one way to fix this is to have type int as the target variable on the left-hand side, or the assignment variable. And look, the compiler does not complain about this. So let's verify that this works by kicking this value out as output I1. We see the value 23. Rule number 2, if one of our operands is a long, L1 equals 1, 2, 3, 4, 5, 6. And let's say we wanted to subtract I1 from L1 and put it back into a variable, I2, which is of type int. The compiler will not like this because of rule number 2. Okay, we have a type long in our expression. So to fix this, we would need to make our variable on the left-hand side of the equal sign a type long. Rule number 3, if one of the values is a float, then the entire expression is promoted to a float. Now notice how the Java compiler does not like this assignment, because the compiler is thinking that this is a type double. So in Java, you need to explicitly add the F to signify it's a float. So let's add L2 or L1 to F1. And let's assign it into L3. Again, Java does not like this because of rule number 3, hence the red squiggly line. So let's change this to a float, F2. And notice how Java doesn't have any problems with this. The last rule, number 4, double D1 equals 1, 2, 3, 4, 5, 1, 2, 3, 4, 0.567. Suppose we wanted to add other variables from above, f1 plus f plus L1 plus I1. And let's say we wanted to store it into an integer value. I2 equals D1 plus F1 plus L1 plus I1. The compiler isn't going to like that. Suppose we don't have the rules readily available, so we want to store it into a long, and we say long L3. Again, the compiler is not going to like this. We try float F3. Compiler is not going to like this. So now we know about the rule. When we apply it, we say D2, and notice how there's no red squiggly line underneath this. Okay, this was Java Primitive Types Part 2. What's called widening, where we go from lower capacity to higher capacity storage. Capacity storage for primitive types. In our next lesson, in Java Primitive Types Part 3, we will talk about the concept of narrowing by using what's called a cast.